Okay, we're on page 7 of the 5.2 notes. I think 7's so ugly. Like, why use those big, huge numbers? What point are we making here? So I threw it out. I took the liberty. So that leaves us with 2 more problems. So let's work on 8 and 9. 8 gives students a little bit of a hard time. I think mostly because there's not very many numbers and letters seem to be confusing. But I like it because a lot of students think these two things are the same thing, and that's not true. This means r minus s times r minus s. This is a difference of squares, so it means r minus s times r plus s. So these are not the same thing. So this is a difference of squares. This can't be factored. You can just write it out twice as r minus s, r minus s. So no place to begin but here. So difference of squares. And if you want to label them like I am, that's probably a good idea because, like I said, students struggle a little bit with the letters only. So that turns into r plus s, r minus s, because this says the signs will be different. And then this, there's no factoring, but you can expand it into r minus s times r minus s. That's what something squared means. Just like when it's r squared, we write r times r. So when it's r minus s squared, we write r minus s times r minus s. So when we have 3 sets of fractions and we see division, division, please excuse my dear Aunt Sally says go left to right. So if one had been multiplication, one division, you still go left to right because multiplication and division are on the same level. So whether they're both multiplication, both division, or one of each, you go left to right. So for right now, we can just ignore this one. So we're going to do, bring our red back, keep, change, flip. So we kept our first fraction as is, change this to multiplication. Now we're going to flip our second fraction. So let's go over to the side and work on these. So r squared minus 2rs plus s squared. Remember, this is going to go in the denominator. So this is the one that confuses students because there's no numbers, but you just have to remember there's imaginary ones in front. So what you should notice is that this is, well, first off, you might want to put a 1 there. This is just a double bubble. It's a trinomial with leading coefficient 1, so I can do r and r. And then this says the signs will be the same. See, what I do when I see a really complicated, I just take one problem at a time. I take this, I do this. I take this, I do this. I don't look at the big picture. I just do a little bit at a time. Otherwise, it just rattles you, to go, oh my gosh, look at all these R's and S's and signs. And, it's just crazy. So now put our minus in. So we're looking for factors of 1. 1 only has one set. That add to 2, that would be it. So it'd be 1s and 1s, or just s and s. And let's say you're not convinced you did it right. FOIL, r squared minus 1rs minus 1rs is minus 2rs plus s squared. So it is indeed correct. And then let's look at the second one. We'll move it up here. So r squared minus rs plus R squared minus, oh, gee, wow, do you guys notice what I just did? I put it in the numerator. Remember, this gets flipped, so this should be R minus S down here. So that was this one, and it goes into the denominator. And then this one's going to go in the numerator, minus RS plus S squared. Well, this one, I can tell, is not factorable. Can you tell that? So can you tell the difference between this and this? Everything the same but this. So this says, what are factors of 1 that add to 1? Well, there are no factors of 1 that add to 1. The factors of 1 add to 2. So yes, no. There are factors of 1 that add to 2. There are not factors of 1 that add to 1. So what happens? That means it just stays the same. R squared minus RS plus S squared. Okay, so for right now, we're just going to deal with this. Not much we can do, it looks like. The only thing we can do is R minus S, right? Nothing else, because these are all in the denominator. Okay, so then keep, change, flip. So let's draw our arrow this time to remind ourselves. So this will be R minus S times R minus S times R minus S times R minus S. So 4 times when we move that up. It doesn't have to be factored, it just has to be expanded so we can simplify. Division we changed to multiplication, now flip. So this you should recognize as a sum of cubes. So we do the little parenthesis and then we do the big parenthesis. We do same, opposite, always positive. We do cube roots, which is R and S. And then we square, multiply, square. Square the first term, multiply the 2, square the second term. So now we are ready to cancel like maniacs. 'Cause notice it's multiplication. So as long as one thing's in the numerator and the other's in the denominator, even if they're not side by side, it doesn't matter. Like these can cancel. As long as one's in the numerator, one's in the denominator, and all there is multiplication in between. So we're going to go crazy. So 1, 2, 3. So I see 3 R minus S's, 3 R minus S's. Boom. So those are gone. So the fourth one was here. So those are all 1. R plus S, R plus S. Anything divided by itself is 1. And look at this. Ding, 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 ding. Yes. This whole thing cancels with that whole thing. So out of all that ugly mess, look at that. Really? Really? So 1, 1, 1, 1, 1, 1, R minus S. Nothing, 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 nothing. So it's R minus S over 1, which is R minus S. Can you believe that? So that's a little bit heavy duty for a test question, I think. It's kind of cool. It shows you the difference between something like this, something like this. It has all kinds of factoring, double bubble, difference of squares, sum of cubes, but it's a little bit tricky. But I could totally see 9 on a test, so I'm loving 9. So, remember what I said, left to right. So right now we're going to focus on this. Okay, because multiplication and division are on the same level, and please excuse my dear Aunt Sally, so it says go left to right. So let's pretend this doesn't exist. So it's multiplication, so I don't have to do any keep, change, flip. So here I see GCF X. When I take an X out of there, I have 1X left minus Take an x out of the second term, 3. So that's just a plain old GCF. Here we have double bubble. Factors of 12 that add to 7, 3 and 4. This says they'll be the same. And this says they'll both be negative. So -3, -4. So we go down here and do x minus 3, x minus 4. And remember how I taught you the quick check. X squared, yes. Minus 4x minus 3x. Yep, that gives me -7x and positive 12. So in 10 seconds, you can do a mental check just to make sure you're on the right track. Second one is just x minus 3. There's no exponents and no GCF, so that's going to stay as is. And then here, 2 terms. Remember, we checked GCF first, and there it is. Take an x out of each one, and we get x plus 6. So since this is first, we'll cancel and write what's left. So x minus 3 and x minus 3. And keep in mind, I could have done these or those. Doesn't matter. And then I have an x divided by x, 1. So what do I have left in that first set? I have 1 times x minus 3 over x minus 4, x plus 6. So first parentheses done and ready. So then we go flip. So keep, change to multiplication, flip. So I kept the first one as is, change this to multiplication, now flip the second. So in the denominator, 6 times x, nothing going on there. In the numerator, though, we're going to factor this double bubble. Factors of 24 that add to 10 would be 4 and 6. Same signs, both negative. So that'd be x minus 4 and x minus 6. So we kept the first answer, changed to multiplication, flipped. And it looks like we are done except for this. X minus 4 divided by x minus 4 is 1. So I don't see anything else going away there. We can't do this. These aren't opposites because this one is -6 and positive x. This is positive 6 and positive x. So the x's don't have different signs, so they cannot cancel. So it's looking like x minus 3, x minus 6. And then usually when we have a monomial, which means one term with no addition, subtraction, anything, that goes in front, and then x plus 6. And remember, these cannot be canceled. Why? 1, because they're not the same. 2, because they're not opposites. In order to be opposites, the 6's would have to be different, and the x's too, and the x's are not. So that's looking like our answer. Okay, 5-3 is a tough one, so enjoy these first 2. And then we have something to look forward to in 5-3. Not. Okay, see you in the next video.